So now that we have covered the installation and the verification, we can move on to our first piece of TensorFlow training. Now, throughout this series, I will be referring to this template slide always. Okay. So first of all, we need to know certain concepts and then we need to implement it. Concept wise, a typical data science workflow in itself happens like this. We prepare some data first. Okay. So we are trying to build a virtual assistant. We need data on text, right? We need chat data so that we can build a chatbot. We want to build a face detection. We want 100,000 images of faces so that our algorithms can learn to recognize the faces, right? So at whatever point we start, we need to prepare the data. For this example, since this is going to be our first TensorFlow example, we are going to cook some dummy data here. Okay, so we are going to generate some data, and this will be house size and price data. So basically, what I'm saying is we will cook up or generate some data on house prices, wherein we will have house size and the price. Okay, so given, let's say you have a 2,500 square feet home, it will set you back by let's say about 8 million rupees or something. Okay, so we'll generate some data like this. We'll have the house size and we'll have the house price. Okay, the inference that we will try to draw is we will try to come up with this equation where price equals size factor times size plus price offset. Now I'm sure many of us know this equation as linear regression. For those who do not know, don't worry about it. This is just a term. So what I'm trying to say is we will try to predict the price of the house given its size. So we can all agree upon the fact that the size of a house has a lot of dependency on what its price is going to be. So let's say a 500 square feet home will not be as pricey as a 2,500 square feet home. There are many other factors that come into the picture. For example, the location of a house and whatnot. Many other factors that come into the picture. To keep things extremely simple, we are only going to concern ourselves with this one variable, which we will call the independent variable. And this will be the dependent variable. So basically, we are going to use the house size to predict house price. How? By the equation that we just saw there. So price equals the house size times size factor plus price offset. So we know what the price is, we know what the size is, we don't know what the size factor and the price offset is. Okay, TensorFlow will help us compute these two. Okay, so we have two missing pieces in this equation. TensorFlow is going to help us find these parameters. So this is the problem that we are trying to solve using TensorFlow. A very tiny problem, but the goal here is to not build the best house price predictor in the world. The goal is we are going to step through this very small and simple example so that we can concentrate on the TensorFlow bindings that are there with each and every steps. Okay, so one more thing we need to do is loss measurement. We'll do that using mean squared errors. Okay, so what is this thing? Let's say we have some house prices. So let's say this is 8 million, this is 7 million, this is 6 million, and so on. Okay. Now, what we are doing is we are making some predictions, right? And let's say for this house, we predicted 6 million. And then for this house, we predicted 8 million. And then whatever. So for this, we predicted, let's say, 7 million. So we are going to make some mistakes on our predictions. We are going to make some mistakes. How do we measure these mistakes? So we take the difference and then square it up. So in this case, it will be 8 minus 6, that is 2, squared, which is 4. 7 minus 8 squared, that is minus 1, squared, which is plus 1. And these are all in millions, I guess, right? Uh, the unit does not matter for this, okay? So in this case, this will be 6 minus 7, so minus 1 squared, which will be 1, okay? So essentially what I'm trying to do here is I want a statistical measure through which we can calculate what are the errors we are making with our predictions so that we can do it better in the next iteration. Okay. So unless and until we know how to measure our errors, we won't be able to go forward. Okay. So definitely we need to measure our errors. On the last step, we are going to employ a gradient descent optimizer to minimize this error. Okay. So first off, we are going to make a lot of errors on our prediction, and typically this is how human expertise also develops, right? So let's say your first cycling experience or your first swimming class, you were not able to do anything. Uh, but as and when you progressed, you became an expert. Similarly, we are going to start with a very bad equation and we are going to come up with horrible predictions. We will measure how erroneous we were, and then we will try and learn from those errors so that in the next iteration, we make fewer and fewer errors as we go along.